Hello, my name is Zara Khan and I'm taking Physics 2211 and this is my first lab presentation on constant velocity. And so the main idea of this experiment is to understand the constant velocity of an object in motion and its relationship to Newton's second law. And Newton's second law, otherwise known as the momentum principle, basically just says an object's acceleration is dependent on net force being applied to the object as well as the mass of the object, and net force is just the force applied to the object over time. And if the net force is zero, which in this case, in this experiment it is, the object is at rest or at constant velocity, which is just the object is not speeding up or slowing down, it's just at the same rate over all throughout. And the main question of this experiment is how is position and time related when a moving object has a net force of zero. So the purpose of this experiment is to observe the motion of an object with a constant and unchanging velocity, and we're going to be comparing our two methods. The first one's experimental, which we are going to be using tracker to track data from when the ball is moving, and computational method is our code in GlowScript. And so there are three formulas that are going to be important to us in this experiment. The first one is just Newton's second law of motion, which is force is equal to mass times acceleration. And then this is a velocity updated formula, and this is a position updated formula, which is going to be useful to us in our computational method in our GlowScript code. And so here are just diagrams of Newton's second law of motion. Here's a free body diagram, but we're actually going to be ignoring two components, friction and the applied velocity, because again, we are just trying to observe the motion of an object with a constant and unchanging velocity. So we are going to have to ignore these components because they kind of they disturb this main observation. And so this is my tracker video. I'm just going to play it real quick. So I just did a ball, and as you can see, there is a negative slope trend in tracker for the data. And so basically our conclusion for this video is that just that the relationship between time and position is negative as the object moves at a constant and unchanging velocity, or like has a net force of zero. So this is the first part of my GlowScript code for our computational method. First off, the mass of the ball is left at 1. The initial position, I got this from the first row in the tracker data. And then I calculated the velocity using the same data. I took the second time, which is 0.033, subtracted by the first, and did the same thing for position, and left with this. And then 0, and then the size of each time step, 1/30, because in tracker said that there were 30 frames, so the size of each time step would be 1/30. And this part of the code is most relevant to Newton's second law. The updated velocity and position formulas are implemented here. And of course, we can't forget that there's net force of 0, so change that here. And yeah. So here we can see the results side by side. The blue is tracker, otherwise known as the experimental method, and then GlowScript is the orange, the computational model. And they both show the same trend, that position and time are inversely related. I guess there is kind of like differences because especially in tracker, especially when when I was clicking the average position for each time frame, maybe that was just not as precise, but either way the results are the same. Yeah, the same conclusion. Additional questions. If you were to flip the axes, I guess the only thing that would change, the results would be the same, but the only thing that would change it would be a positive slope instead, since you're flipping them. But yeah. Is it possible for you to say how many pushes and pulls? I don't think there's a plausible explanation since we don't know the exact coordinates, so I guess it just can't be determined. But yeah, thank you.